Hey y'all, Mr. Thibodeau here. We got lesson 32 for you. Okay, it's a short week, so just a little bit, but here's what we got. You got your mental math, problem solving, new concept. A plane is a flat surface that extends without end. So a piece of paper, okay, a thin, two-dimensional piece of paper, where you really only have a two-dimensional surface to write on, is considered a plane. Except that technically a plane extends everywhere, or extends in all directions, okay, and continues to do so indefinitely, okay. What does that really mean? Well, we use it when we're talking about trying to do things in space. Technically, space is 3 dimensions, but we often will talk about it within a two-dimensional concept when we're mapping some things out. It is helpful for us to kind of conceptualize some things in geometry. It is an abstract, though, right? Like, very few things actually extend forever, right? And two-dimensional especially. So it is kind of an odd concept sometimes, but it helps us when we're dealing with things in higher ends of math. But it should still be relatively easy for you guys to deal with, though it is sometimes hard for you to think about. So it's like a thin piece of paper. You can draw anything you want on one side. It has no depth to it, right? It's not three-dimensional. No matter how lifelike you make it look, it's still only two-dimensional. But it continues forever in all two-dimensional directions, right? So up, down, side to side. It doesn't go, there's no height to it. But other than that, okay. So let's see. A polygon is a flat shape formed by line segments that close in an area. So all of these shapes are a polygon, okay. This guy right here is not a polygon because it is not enclosed, okay. This is enclosed, and this one is not a polygon because it's not flat. Now technically it is flat, right, because it's on a flat plane, but it is representing a three-dimensional figure. So this, of course, is confusing. This is supposed to represent a three-dimensional figure, but as we just talked about, it is on a flat piece of paper. There's no, so it's a little silly, where it's like, oh yes, this is 3D, but it's not. It's two-dimensional, right? This is technically a polygon because it's on a piece of paper, but it's representing a three-dimensional figure, so it is not a polygon as far as what this is concerned. So, that's fun. But generally when we're talking about polygons, they look like these things, okay? All of these things are polygons, okay? They don't necessarily have to be, some of these polygons are regular, which means that the sides are the same, okay? Other polygons like this one are not regular, okay? There is a way to make a regular decagon. There is a regular way to make a dodecagon, but these are not it, okay? Four-sided polygon is called a quadrilateral, okay? 4 sides that are lateral. There are different kinds of quadrilaterals. Squares, rectangles, parallelograms, and trapezoids are all technically quadrilaterals because they all have 4 sides. They're just done differently, okay? So square, we got our trapezoid, okay? And we got a number of other ones that we'll see as well. All right, so which was a... sorry guys, which one is not a quadrilateral? Well, this guy, right? Which of these is not a polygon? Ooh, interesting. C is not a polygon because it is not flat, okay? So when we talk about polygons formed by line segments, okay? So flat straight lines, okay? This one is not actually a polygon because it is got a curve to it. It should be flat, okay? These are all polygons, okay? hexagon, dodecadon, and octagon. Congruent is a good vocabulary word. It just means equal, the same. Okay? These are all equal to each other. They're exactly the same. They're just in different positions. Okay? So this side here is completely equal to this side, equal to this side. The angles between them are all equal. Okay? So this one here, I'll label it 1, is the same angle for all of them. Okay? Okay, rectangles are congruent. Well, it looks like A and C are, they're just in different forms, but you really can't tell from here. Now there's also similar, okay, where the size is different, but the angles are the same. So the size is different, but the angles are the same. And that ends up being very, very important for us because we are able to use triangles that have the same angles to solve all sorts of different problems, okay? Because triangles that are similar have similar ratios between their sizes. So let's say if this one is 4 and this one is 2, then this one is 8. So 4 to 2 means that 8, this has got to be 4, okay? So 2 is half of 4, so that whatever this one is has to be half of whatever that one is, okay? So that is a way of solving these, okay? And then, not to blow your mind, but this one would be 2 times the square root of 3 and 4 times the square root of 3. That's a whole nother deal. You don't have to worry about that for like 3 more years. So, okay, so which two triangles below are similar? So B and D are. Yeah, that's what I got for you. Your written practice, I want you guys to do. Let's just do 1 through 29 odd. Okay, so just the odds. Over here, I'll get onto the lesson practice. Draw a triangle with 2 perpendicular sides. Now, perpendicular means that they match and create a right angle, okay? So that would be a triangle with 2 perpendicular sides. Wait, 2 perpendicular sides? I think it just means like this side and this side are perpendicular to each other. If it wants 2 separate sides that are perpendicular, there's no possible way. Yeah, so assuming it is talking about this side and this side are perpendicular to each other, then that is how you would do it. If it wants you to somehow create a triangle that has a perpendicular side here and a perpendicular side here, that's not going to work, right? There's no possible way that that's going to be a triangle because you already have too many things. That's going to be 2 triangles, okay? Or it's going to be a rectangle. So I assume this is what they're asking for. A quadrilateral is a polygon with how many sides? 4. Quad means 4. Draw a quadrilateral that has 1 pair of parallel sides. Okay. Only 1 pair of parallel sides would be something like this. It would be a rhombus, right? The trick here is only doing one that has 1 side of parallel because these lines mean parallel. Because, right, if you draw like that, that's going to have 2 sides that are parallel, or 2 pairs of parallel lines. Okay, which is then going to be that guy. So this is your answer for C. This is your answer for D. Draw a quadrilateral that has no parallel sides. Okay, so that's just like bloop, 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 bloop. Okay, so still a quadrilateral, but none of those are parallel. Because if we continued to draw them forever, right, they would ultimately hit each other, okay? It would keep going forever. and they would ultimately cross paths. Okay. Name each figure. So 1, 2, 3, 4, 5. So 5 sides is, tells us right here all the stuff, right? Pentagon. These aren't a regular pentagon, but it is a pentagon. 1, 2, 3, 4, 5, 6 sides. Okay, so that's going to be your hexagon. So relatively simple stuff. 1, 2, 3, 4, 5, 6, 7, 8. So octagon, right? Octagon, 8 sides. Relatively straightforward. Just kind of some odd stuff. We'll get more into that as we go. So if it doesn't make too much sense right now, don't worry about it. It brings it up a little bit, and then it comes back to it over and over again. Okay. Excuse me, guys. Well, that should work.